Arithmetic sequences and sums. A sequence is a set of things, usually numbers, that are in order. Each number in the sequence is called a term, or sometimes element or member. In an arithmetic sequence, the difference between one term and the next is a constant. In other words, we just add the same value each time, infinitely. Example: 1, 4, 7, and so on. This sequence has a difference of 3 between each number. The pattern is continued by adding 3 to the last number each time, like this. In general, we could write an arithmetic sequence like this: A plus D, A plus 2D, and so on, where A is the first term and D is the difference between the terms, called the common difference. Our example has A equals 1, the first term, and D equals 3, the common difference between terms. And we get A plus D, A plus 2D, and so on becomes 1, 1 plus 3, 1 plus 2 times 3, and so on, which is 1, 4, 7, 10, as we wanted. We can write an arithmetic sequence as a rule. X sub n equals A plus D times n minus 1. We use n minus 1 because D is not used in the first term. Example: write a rule and calculate the 9th term for this arithmetic sequence: 3, 8, 13, and so on. This sequence has a difference of 5 between each number. So A equals 3, the first term, and D equals 5, the common difference. Using the rule, X sub n equals A plus D times n minus 1, which equals 3 plus 5 times n minus 1, which is 3 plus 5, n minus 5, which is 5n minus 2. So the 9th term is x sub 9 equals 5 times 9 minus 2 equals 43. Is that right? Check for yourself. Note that arithmetic sequences are sometimes called arithmetic progressions or APs. Advanced topic: arithmetic series. A series is what we get when we add the terms of a sequence together. In other words, a series is a sum. First, let's learn about sigma. This symbol is called sigma. It means add up. The numbers below and above show the starting and ending values. This example says add up n, where n goes from 1 to 4. The result is 10. Now let's use it to add up the terms of a sequence like this: A plus D plus A plus 2D, and so on. We can find the sum using this special formula. It says that adding up A plus K Ds, where K goes from 0 to n minus 1, equals n on 2 times 2A plus n minus 1 times D. Here is how to use the formula. Add the first 10 terms of this sequence: 1, 4, 7, and so on. A equals 1, the first term. D equals 3, the common difference. N equals 10, how many terms to add up? Our special sum equals n on 2 times 2A plus n minus 1 times D equals 5 times 2 plus 9 times 3 equals 5 times 29, which equals 145. Try to add the terms yourself and see if you also get 145. To learn more about this, you can visit us at mathisfun.com.